Let's study mortars as the third material of this week. Building mortars are workable pastes made of mixtures of binders, aggregates, and mortar. They are used to bind different building pieces together in a whole, fill and seal the gaps between them, and cover their surfaces. The mortar composition is designed by the weight of binding material in 1 cubic meter of mortar. This is defined as dosage. For mortars composed of one kind of binding material, the composition is expressed as 1:4, 1 part by the weight of binding material and 4 parts of aggregate. Mortars can be classified according to their bulk density, kind of binding material, applications, and properties. We can have a heavy mortar with a bulk density higher than 1,500 kg over cubic meter, and sand can be used as an aggregate in this mortar, or if we prefer to use grounded pumice or slag with a bulk density lower than 1,500, we will have a light mortar. The governing factors in deciding a particular type of mortar or binding material depends on the desired strength, resistance to water, appearance, hardening conditions, cost, and so on. Cement mortar is prepared with Portland cement or its varieties, sand and water. Portland cement and blast furnace slag cement form excellent mortars for masonry. Pozzolana cement and sulfate-resisting cement form mortar for surfaces exposed to aggressive and wastewater. Lime mortar is a mixture of fat or hydraulic lime, sand, and water. Fat lime has high calcium oxide content. Its hardening depends on loss of water and absorption of carbon dioxide from the atmosphere. Lime mortar is not suitable for waterlogged areas and damp situations. Gypsum mortar is prepared with plaster of Paris or anhydrite. Mud mortar is prepared with clay. This is the cheapest type of mortar prepared with locally available ingredients. To improve resistance to rainwater, the surface of placed mortar can be sprayed with bituminous materials. Composite mortar may contain Surkhi lime water, lime Surkhi sand water, cement lime water, or cement clay water. Lime cement mortar has increased water retentivity, workability, better bonding properties, and frost resistance. The main properties of hardened mortar are strength, development of good bond with other products, porosity, resistance to weathering, cost, durability, appearance, and 4 green mortar mixes, mobility, placeability, and setting. In mortars, binding materials can be cement, lime, gypsum, and clay. They are used to impart adhesive power and strength. Sand, as an aggregate, increases the compressive strength of mortar and reduces shrinkage. When used in lime mortar, it assists the hardening of fat lime by allowing air to penetrate, providing carbon dioxide for carbonization. Surkhi, it's grounded brick. We can say that it's grounded brick, is used for economy and for furnishing hydraulic properties of lime mortar. Or we can use Flyash as fine aggregate. Water in mortar lubricates the surface of aggregate, spreads the binding material uniformly so that it can fill the pores in fine aggregate and cause hydration. Grout cement mortar of fluid consistency used to fill the voids and joints in masonry and to repair the cracks is known as grout. Grout differs from mortar in its fluidity, and it is to be poured. It's essentially composed of cement, fine and coarse sand, water, and a small amount of grouting admixture.